That sounds like a 4th of July celebration, but it isn't really. It's just Tom on his way to school. Wouldn't Tom be surprised if somehow we could turn off the sound when he strikes that can and that box? Of course, we're just pretending. We can't really turn off the sound. We all know that if you strike an object, it usually makes a noise. But do you know why? Do you know what causes sound? Why are some sounds different from others? Here are several experiments you can perform to answer these questions and to learn more about sound. A yardstick lying on the table does not make any noise, but if we snap it so that it moves up and down rapidly, it makes a clattering noise. When it stops moving, the sound stops also. A rubber band doesn't make any sound either, but if you pluck it so that it moves back and forth quickly, it does make a sound. The sound dies away as the rubber band stops moving. We are beginning to learn that an object makes a sound only when it is moving. In fact, all sound is caused by movement. If nothing on the earth ever moved, there would be no sounds. When water moves, you hear a splashing sound. When the leaves of a tree move back and forth, you hear a rustling sound. When a door slams shut, the wood of the door is moving back and forth quickly. Any rapid back and forth movement is called vibration. We made the yardstick vibrate. We made the rubber band vibrate. And we can even make the air in an empty test tube vibrate. When we blow across the top of the tube, the air inside moves up and down quickly, and this makes a whistling sound. Most of the objects that make sounds vibrate so rapidly that you cannot actually see them move. For example, it's almost impossible to see this bell vibrate, although you can hear the sound. In order to prove that it does vibrate, tie a small iron washer to a fine thread and hold it lightly against the bell. If the bell isn't ringing, nothing happens. But when you ring the bell, the washer bounces away because the vibration of the bell is pushing it. Now we know that sound is caused by vibration, but in order to hear the sound, these vibrations must reach our ears. How does this happen? For instance, how does the sound of the electric bell travel to our ears? When the bell rings, it vibrates very rapidly and pushes against the air around it. This rapid pushing makes sound waves in the air, which travel away from the bell in all directions. If the waves reach our ears, we can hear the sound. Of course, you cannot really see sound waves, but they do travel something like this. Most of the sounds that reach our ears travel to them through the air. Can sound travel through other materials too? Suppose we put this toy frog underwater. Will the sound travel through the water to our ears? Listen closely. Let's try another experiment. Do you think that sound can travel through wood? Hold one end of a stick of wood against your ear while someone else scratches the other end of the stick. Can you hear the sound? These experiments have shown that sounds can travel easily through water and through solid materials as well as through air. Are all sounds alike? Here is one way in which sounds are different. We say that one sound had a higher pitch than the other sound. This rubber band makes a higher pitched sound because it vibrates faster than the other rubber band. The faster an object vibrates, the higher the pitch. Do you know why these two rubber bands vibrate at different speeds? The reason is that one rubber band is shorter than the other one, and therefore vibrates faster. The metal bars on this toy xylophone are different lengths. The long bars vibrate slowly and make low-pitched sounds. While the short bars vibrate more rapidly and so make higher-pitched sounds. The shorter the object, the faster it vibrates. This test tube produces a low-pitched sound when you blow gently over the top of it. But if you pour some water into the tube, it produces a higher pitch sound. By adding water, you reduce the amount of air in the tube. A shorter column of air vibrates faster and therefore makes a higher pitched sound. Now see what you can do with a row of test tubes filled with different amounts of water. You have learned a few important facts about sound. That sound is caused by vibrating objects. That sound waves travel through air, water, and solid materials. That the faster an object vibrates, the higher the pitch of the sound. And in order to learn more about sound, see if you can find the answers to these questions. How does a piano make sounds? Why are some sounds louder than others? What makes a cuckoo clock cuckoo?